Okay, trig functions of any angle. We're still talking about right triangles because trig functions only work for right triangles. But so far we've only looked at the trig functions of acute angles because all the angles have been inside of a triangle. Today we expand our view of trig functions to include all angles, not just acute angles. So to do this, we're going to look at angles with respect to a coordinate plane with the initial ray in standard position. So we are going to look at angles outside of quadrant 1, and we're going to move into quadrant 2, 3, and 4. When you do that, our definitions for the trig functions will change just slightly. We will think of sine of theta as y over r. Now that still is opposite over hypotenuse, but do you see that now this doesn't, the angle right here that's obtuse doesn't make a right triangle anymore. It does if you drop a perpendicular this way, and that's what we're going to do pretty soon. We're going to call that a reference angle for this giant angle, but if we're looking at this big one, we cannot make it into a right triangle. So we're going to think in terms of r, where r, if you want to think of it kind of as a radius, it will still be our hypotenuse. Y will still be our opposite, but we're going to kind of change how we look at it in the other quadrants. Our cosine will be x over r, where r is again similar to the hypotenuse and x is similar to the adjacent. Tangent is y over x. Cosecant will be your flip of sine. Secant will be your flip of x. And cotangent will be your flip of tan. Now we're going to write something down that might not mean anything to you, and some of this doesn't mean anything to you. It will all come together by the end, I promise. But I want you to know that sine always refers to the y's, and cosine always refers to the x's. It's page 14. Again, that may not mean anything to you right now, but we'll just give me a minute and we'll all come together. So now that we're looking for trig functions in quadrants other than quadrant 1, a reference angle is going to be used. The actual angle is theta, so up here, this will be our actual angle, and the reference angle is going to be over here, right here, and it's going to be called theta prime. All reference angles are relative to the x-axis. What that means is when you are looking for an angle that's in a different quadrant, and you are going to use a reference angle, we're going to drop a perpendicular to the x-axis. You will never, ever drop a perpendicular to the y-axis and make a right triangle with the y-axis, ever, 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 ever. You will always make your reference angle with respect to the x-axis and drop a perpendicular to the x-axis. And what we're going to end up doing is using this right triangle to help us to get the trig functions for this angle. All reference angles are relative to the x-axis. So for example, if theta is 135 degrees, let's call this one 135 degrees. Let's call this one our theta. Then we are going to use this angle, theta prime, which is 45 degrees, as our reference angle. To find the sine of 135 degrees, we're going to find the sine of the reference angle and apply the appropriate signs for that quadrant. So what does that mean? We know that a 45-degree angle, do y'all know how I got 45? Because it's supplementary to the 135. Okay, so 45. We know that the sides of a 45-degree angle are 1, 1, and root 2, don't we? But we have to be super careful because our signs change. When you go to the left on the x-axis, we will have a -1 here. So we taking the signs into consideration, signs being S-I-G-N-S, the positives and the negatives into consideration, if I wanted the sine of 135 degrees, I'm going to use my reference angle and I'm going to say, ooh, it's opposite over hypotenuse. It's the same as if it were in quadrant 1. But my cosine of 135 degrees is not root 2 over 2. It's negative root 2 over 2, isn't it? My sine is going to change for the cosine over here. It would be adjacent over hypotenuse. So let's go ahead and let's find the reference angle for a 255 degree angle and for a 9 pi over 5 degree angle. Let's see, I'll just kind of drop here. If I wanted a reference angle, so 255 degrees is outside of quadrant 1, it would be with my initial rate here, 90, 180, 270, ooh, that's too big. But isn't it going to be somewhere down here? This is the angle that we're talking about. Is this big giant angle. But I can turn this into a right triangle using a reference angle, dropping to the x-axis. This becomes my reference angle. Right here. And the size of that reference angle, theta prime, is, well, if it's 255, isn't 180 out to here? And what's the difference from 180 to 255 degrees? $75 degrees. Instead of saying this is 255 degrees, I will say this is a 75 degree angle in quadrant 3. A 75 degree angle in quadrant 3. And that would be my reference angle. That's going to make this problem a little bit easier for me to figure out. 9 pi over 5. This one is a little bit harder for us to figure out. But this is what I want you to do. This is 0 pi, right? If I am looking at over 5, if my denominator is a 5, isn't 180 degrees pi radians? But if I'm thinking in terms of fifths, isn't it 5 pi over 5 radians? Because the 5s would reduce and give you pi. So 9 pi over 5, we're looking at standard position, and our angle is going to go past 5 pi over 5. How far past is it going to go? Well, let's talk about this. Isn't this one 0 pi, but it's also 2 pi? But if I'm thinking in terms of fifths, wouldn't it be 10 pi over 5? Because that reduces to 2 pi. And so 9 pi over 5 is going to be very close to 10 pi over 5. It's going to be out here somewhere. This is 9 pi over 5. Drop a perpendicular. My reference angle for 9 pi over 5, let's do the quadrant first, because that's easier. It's quadrant 4. And we are looking at it with respect to the closest x-axis. I already dropped the perpendicular for us. How does 9 pi over 5 compare to 10 pi over 5? It's a pi over 5 radian angle in quadrant 4. Because the difference between 9 pi over 5 and 10 pi over 5 is just, this means it is pi, the size of pi over 5, but in quadrant 4. Much easier to do the angles in degrees than it is to do the angles in radians, but it's okay. All right, so what's one of the main points? First of all is that we are going to, when we leave quadrant 1 and we go look at angles in other quadrants, we're going to drop perpendiculars to the nearest x-axis and we're going to find a reference angle to help us out. And then we'll use the signs, S-I-G-N-S, of our x and y axis to help us figure out the sine, cosine, and tangent. But the second thing is that, and you've noticed it, our SIGNS's do change as we move from quadrants. And so that's what this page has to do with. This little picture up here has to do with the signs of our trig functions in different quadrants. Okay, this picture right here is for memorizers. I'm not a memorizer. I want things to make sense because then I don't have to memorize. But I'm going to show you how to memorize if you need to. If you are in quadrant 1, all of your trig functions are positive. Doesn't that make sense? Isn't that what we've been doing? We've been doing all these little like 30, 60, 90s, and all of them have been positive. If you move to quadrant 2, just your signs are positive. Everything else is negative. We have to keep in mind the flip of sine is cosecant, so cosecant would be positive also. Down in quadrant 3, just your tangent is positive. And in quadrant 4, just your cosines are positive. Students taught me this. Like I said, it's for memorizers. All students take calculus is how to remember. I see some nods in here. How to remember where your positive trig functions lie in different quadrants. Again, I don't like memorizing, so I'm going to do this a little differently. But the first questions that ask about this are in which quadrant does theta lie? This is how I do these because, like I said, I just don't want to memorize. The only thing that you have to memorize in doing it this way that I'm about to show you is that sine always refers to your y's and cosine always refers to your x's. Sine y's, cosine x's. And you are going to have to know that for other reasons too. So, sine is negative. This is a fancy way of saying your signs are negative. Well, you can memorize where the signs are negative, or you can go, hey, signs refer to your y's. Where are your y's negative? Here and here. Isn't that where all your y coordinates would be negative? It's down here where all your y's are negative. Cosine of theta is negative. You can memorize this above. I think that's too hard. I am not, maybe I'm just not a good memorizer. But where are all, it's not cosine is your x's, where are all of your x's negative? Here. Everything in quadrant 2 has a negative x, and everything in quadrant 3 has a negative x. If your angle has a negative sine and a negative cosine at the same time, where is that going to be? Quadrant 3. Quadrant 3, if theta is negative, if your sine of theta is negative and your cosine of theta is also negative, that will only happen in quadrant 3, where both of those are true at the same time. Coming over here, where is your tangent negative? And where is your cosine positive? For both of these to be true at the same time. Okay, so this is what I remember for tangent. Instead of saying tangent is negative here and here, I go tangent is negative where your slope is negative. Tangent is positive where your slope is positive. That's just my mnemonic device for remembering it. So where is tangent negative? If tangent of theta is negative, that is going to be in quadrants 2 and 4. And my cosine is positive. Where's my cosine positive? Cosine is your x's. Sine is your y's. Cosine refers to your x's. Where are your x's positive? In quadrant 1 and quadrant 4. Your x coordinate would be positive. Where are both of these true at the same time? quadrant 4. Your theta is in quadrant 4 if this is the situation you've got. Your angle is down in quadrant 4. How are we doing? Where is sine positive and secant positive? Well, my sine refers to, you have to know this,
Y's.
the y's. Where are your y's positive? Up here.
1.
My sines are positive up here and here. Again, you can memorize it. All students, that's too much for me. My secants. Where are my secants positive? Well, secant is the flip of cosine. And just because you flip something doesn't change its positivity and negativity. That doesn't change. So this is asking the same thing as if your cosines are positive. My cosines are positive where my x's are positive. That's here and here. Quadrant 1. All right, last but not least, have y'all already done this one? It's fine by me. Cosine is negative. Cosine is your x's. Your x's are negative right here. That would be points up in quadrant 2 and points down in quadrant 3 would have a negative x value. Cotangent is positive. That's okay, that's the flip of tangent. And just because you flip something and have a reciprocal doesn't change whether it's positive or negative. Your tangents are positive where your slope is positive. That's here and here. Where are both of these true at the same time? Quadrant 3. So your theta is in quadrant 3 if it fits these two scenarios at the same time. We good?
Oh.
All right. Trig functions of, I cannot say this word, quadrantal angles. It's a hard one. Gets me tongue-tied. A quadrantal angle is an angle whose terminal side coincides with the x or y axis. So let's say I ask you for the sine of 90 degrees. That would be where my initial ray is on the x-axis and my terminal ray is on the y-axis. Can I drop a perpendicular to the x-axis and make a right triangle? No. I mean, you might say you can make a triangle right there. No, but I'm talking about what we have done is we have taken the ray and we have dropped to an x-axis. Can I take the terminal ray and drop and make a right triangle? No. So there's going to have to be a different way to work this one. We are going to use what I'm going to call the lowest terms points. 1, 0, 0, 1, -1, 0, and 0, -1. Sine refers to the y's, doesn't it? So we're just going to look at the y coordinate up here at 90 degrees. The y coordinate is 1. So the sine of 90 degrees is 1. You grab the y coordinate. If I asked you for the cosine of 270 degrees, that would be down here. You cannot take the terminal ray and drop a perpendicular to the x-axis. You keep going straight down. That tells you it's a quadrantal angle. And the cosine, it refers to your x's. So we grab our x coordinate. And it's 0. What if I asked you for the secant of pi? All right, we're going this direction. I definitely can't drop a perpendicular to the x-axis. I'm on the x-axis, so I can't get a reference angle. But I do know that secant is the reciprocal of cosine. what is the cosine at pi? Cosine is your x's. And what if I asked you for the tangent of 90 degrees? All right, the tangent of 90 degrees. I said that sine refers to your y's, cosine refers to your x's. But the other day on Friday, I told you that I wanted you to start thinking of tangent as being sine over cosine. So in this particular scenario, we have to convert our tangent to sine over cosine. The sine of 90 degrees, that's the y value at 90 degrees, because sine refers to your y's. Our cosine of 90 degrees, cosine refers to your x's, we're going to use the x value. The tangent of 90 degrees does not exist. And we'll see that a little bit more when we get to. All right, I feel like there's been a lot of pieces to the lesson today. Let's see if we can kind of bring it all together a little bit. Where all of this comes together. Find the exact value of each expression. The sine of theta is -1/2, and theta is between 180 and 270 degrees. I want you to find the exact value for the tangent of theta. Guys, whenever it says find the exact value, I think you need to draw a picture. I just don't know how to do it without. This is too much for even my little brain to handle. I'm going to draw a picture. Put my coordinate plane. It tells me that theta is between 180 degrees and 270 degrees. Isn't that convenient? We know that theta is down there. And so we're going to use this reference angle. It's referring to the big one, but we're going to use this reference angle right here. It says the sine is -1/2. Isn't this my opposite? And isn't this my hypotenuse? So with respect to theta, that's very nice. They've given me the opposite. They've given me the hypotenuse. Do those numbers look familiar to you at all? 1 and a 2? But careful, it's a -√3. When your hypotenuse is double your shortest side, it's a 30, 60, 90. So now can I find the tangent of theta? Here's my theta. Tangent is opposite over adjacent. The negatives will cancel each other out. I'm also going to have to multiply by √3 over √3. There's your exact value for the tangent of theta, given a little bit of information. I don't know how to answer these without making a picture of the information I'm given. I can't do it. Well, maybe I could, but I wouldn't have been able to do it back then. Okay, here's a different question. Tell me how big this angle is. It's opposite the 1. We've got a 1, √3, and a 2. What size is our theta? You're scared.
30.
It's 30. It is 30 degrees. This is a 30-degree angle. which means that we're talking about 180 plus 30, we're talking about a 210-degree angle. This is just extra. This is extra bonus. We're talking about a 210-degree angle, so the tangent of 210 degrees is root 3 over 3. Didn't ask it, I'm just getting you used to it. All right, the next one, the cosine of theta is negative 1/2, and the sine is root 3 over 2. Find the cotangent. How does this bring today's lesson together? Well, we got to find where theta is located. What are we given? The cosine is negative. Cosine is negative. We're either here or here. And the sine is positive. Sine is your y's. We're here, we're here. Where both of these are true, where the cosine can be negative and the sine can be positive, is up here in quadrant 2. So we're talking about this angle right here in standard position, but we're going to drop a perpendicular and make a right triangle over in quadrant 2 to help us out. This is the scenario we've got. Cosine is adjacent over hypotenuse. That puts a -1 right here and a 2 right here. Sine is opposite over hypotenuse. That puts a root 3 here. All of this makes total sense, right? What's the issue? See it?
Yeah.
Okay. All of my signs are right. This should be a negative number going left on the x-axis and a positive number going up on the y-axis, so everything's working out. My cotangent of theta then is the flip of my tangent. Tangent is opposite over adjacent, so cotangent is adjacent over opposite. I have 2 points to make. First of all, that is the answer to this question. If you can get that, you're good, but tell me what size this angle is.
30.
45.
It's a 60. Good guesses. 30, 60, and 45 are all good guesses, but 60 degrees because we're opposite the root 3. Okay, so this is 60. So we're talking about a 60 degrees, we're 60 degrees shy of 180, aren't we? We're not quite to 180. This is a 120 degree angle. The cotangent of a 120 degree angle is negative root 3 over 3. We'll get there. I'm just introducing that this is the answer to that question. Can I make a point? You don't have to write this. If you said the cosine, if I had the cosine of theta is negative 1/2. It's written for you where the negative is clearly with the 1, but you need to know the hypotenuse will never be negative. The hypotenuse will never, only things that will be negative will be your legs because they talk about x values and y values. So don't ever put the negative with the hypotenuse. The hypotenuse will always be positive. All right, find the exact value of each expression. Don't you wish that you could run to your calculators? This one, your calculators actually will give you an exact expression, but this one it won't. So what we're going to do is, did you draw a picture? I would like you to draw a picture. The cosine of 300 degrees, we've got to go find it. I am in standard position, and I'm going to go around and find where my terminal ray lies. 90, 180, 270, 300 is going to be in here. I am talking about a 300 degree angle, but I'm going to use a reference angle. I'm going to drop a perpendicular. If this is 300 degrees, what is this angle right here?
60.
60 degrees, because we're almost to 360, but not quite. If this is a 60-degree angle right here in quadrant 4, do we know that these numbers will go on the sides of the triangle? Watch your signs. It doesn't affect this question, but it will affect future questions. A positive 1, and when you go down, your y coordinate will be negative. So the cosine is adjacent over hypotenuse. The cosine of 300 degrees is 1/2. Again, your calculators would have given you that exact expression, but the secant of 150 degrees. Speaking of, as I'm watching people punch into calculators, your first test on this stuff, which is next week, there will be pages where you're allowed a calculator, and then there will be pages when you're finished the calculator pages, you have to put your calculator away. I'll bring you the other pages. These questions, you will not be allowed a calculator. So you're going to have to be able to do it. So just giving you a little heads up that linear and angular velocity, you're going to use a calculator because you have to plug in. But questions like this, you're not going to get a calculator. Okay, so 150 degrees, we've got to figure out where it is. I'm starting in initial ray in standard position. I am going 90, 180. Okay, so 150 is here. In order to get the secant of 150 degrees, I'm going to use a reference angle, which means I'm going to drop a perpendicular to the x-axis. How big is my reference angle?
30.
30, because we're 150 to 180 is a 30-degree difference. All right, let's plug in my numbers. This is going to be a positive 1. This is going to be a positive 2. This is going to be a negative √3. Secant is the flip of cosine. Cosine is adjacent over hypotenuse, so secant is going to be hypotenuse over adjacent. We've got to rationalize. It will be negative 2 √3 over 3. All right, this down here is where it gets super fun. I say we save that for Wednesday, and then Wednesday we'll finish this and you'll have a quiz. The quiz is not over this section. Your quiz is over 5.1 and 5.2 only. I'm going to stop recording.